Welcome to XplainIT, a demonstrator for explainable artificial intelligence, or more specifically explaining deep one-dimensional convolution neural network for structured data. Deep neural networks have been widely used for various applications, due to which they are gaining acceptance across many organizations and domains. Still, they are considered as black boxes. Various questions arises about the transparency of the model, understandability, how to gain insight from the decision over whole data set, how or why one prediction is made different than the other. There are three well-known explainability techniques, LRP, SHAPE, and LIME, that are commonly used. These techniques have been utilized to answer questions regarding explainability and of deep neural networks, for example, for object recognition, digit recognition, visual question answer, and medical field. However, based on our knowledge, it is not yet used for our structured data. Many organizations use structured data with traditional machine learning technique that they can explain, whereas they did not use deep networks like CNN, as deep CNN are hard to explain and not common for structured data. Companies faces challenges. For example, an end customer will want to be assured that the system is not biased. They will also want to know the reason for a decision, such as why was my loan application rejected and what aspect of their input, for example, loan application, need to change in order to change the system decision. Companies need a clear understanding of the system before deploying it in a real scenario. Correct decisions are beneficial, but wrong decisions present risk for the company, proportional to the impact of the model decision. Regulatory authorities have a remit to impose the rule of law on companies to ensure justice, privacy, and transparency for a customer. That is EU GDPR rule of right to explainability of an intelligent system. Therefore, we developed XplainIT, a web-based, friendly, and intuitive interface with several levels of explanation oriented to non-expert users and advanced users. In both cases, the goal is to improve the decision making in the company and provide answer to the question I previously mentioned. For example, as an end user customer can provide the reason for a decision, such as why was the loan application rejected and what aspect of their input in the loan application needs to change in order to change the system decision. For companies, it can highlight the lack of important features that result in certain customer to churn or leave. So XplainIT can help in retaining them as well as helping in a way to ensure that they are GDPR compliant. It will also help data scientists to learn which are the features that are not needed or have no importance in the decision and can be removed in order to enhance the performance of AI system and eventually reduce cost of processing. Now I will demonstrate. Here you can see this is the home page of XplainIT, where you will see some background information as well as a tutorial video. In addition, you can select the data set that you want to test with. For example, in this case, telecom customer churn data set. Click on start. It will bring you to the main page where you will find some information about the data set, the deep neural network used, and additional technique utilized while training. Then some information about each individual feature in the data set and their additional information, for example, about their distribution, min, max, median values, and whether they are categorical or non-categorical, and how the data set is distributed in negative and positive class. Coming to local interpretation, we will first discuss local interpretation for a single record or local analysis. Here you can have a brief description about local interpretation for a single instance. You can select a specific record from the testing set or slide it that is being provided. There are a total of 1407 samples. You can drag or click on this line, and in real time below you will see the new results as a textual explanation or in the form of a heat map. Above that you will see the confidence level of the classifier, the real value, and the predicted value. You can also see the real information or the real record values, the normalized form of that input, and the features, just to know what each feature here means and how the original data was. You can also have some additional information about the technique used for visualization. For example, in this case, layer-wise relevance propagation, and what each color in the heat map means. Below that is the textual explanation that could be used for a layman or an end user, which shows the important feature based on which the system predicts whether this person will churn or not. Going to global analysis. But before that, just to highlight, the use of info boxes or text explanation will allow a non-expert user to understand the result of prediction more easily. And on the other hand, the use of several types of charts offer the opportunity to an advanced user exploring more in detailed pattern or hidden behavior of the model, or even it could help to improve the model in terms of feature selection. Here you can see the behavior of the model over the whole data set or subset of the data set. For example, considering the true positives or true negative or false positive or false negative or total as a whole, and each by selection each you will see clear pattern of features showing importance in for that decision. Similarly, you can see for Lime and SHAP. For SHAP we also provided box plot, which is another form of visualization that is commonly used with SHAP, but for the help and understandability we have added that feature as well. Now the final page shows a form that could be filled as a new record for that could be given as input to the classifier. Here you can select values and change the sliders or switches based on which in real time it give input to the classifier and it classify it and showed what are the important feature in that. For example, for this case, contract month to month is an important feature for churn. If the contract is monthly, there is a big chance that the customer will abandon the business because of contract month to month and fiber optic. Similarly, for Lime, you can visualize as well, but it will take about 15 to 20 seconds. On the other hand, SHAP is far more time consuming and it takes around 1 minute for processing one single record. So LRP is much faster compared to Lime and SHAP. There is a tutorial as well that you can read. It's the same. So to go back to try another data set, you can click on reset, click yes, and then select here the new data set. Thank you for watching. If you like it and want to explore your deep model with your own data, or want to provide your data so that we can explore it and train a model on it, kindly contact us and we can discuss possibility of how we can help you in understanding your system. Thank you for watching. Goodbye.